If your phone gets smarter, if your car drives itself, if AI continues its explosive growth, the tiny, powerful chips inside are the reason why. But the future of that technology, a future once controlled by a tiny handful of companies, is now at the center of a geopolitical firestorm. So, guess who might be behind the next leap forward? The answer could rewrite the rules of global tech. Because according to explosive new reports, China may have cloned an EUV machine. And that's a very big deal. EUV, or extreme ultraviolet lithography, is the magic wand of modern electronics. It uses incredibly short wavelength light to etch microscopic circuits onto silicon wafers, creating the 3 nanometer and even 2 nanometer chips that power everything. Until now, only one company on Earth, ASML in the Netherlands, could build these city bus-sized marvels of engineering. But that monopoly might be over. Quick break. If you want to stay ahead on stories like this, subscribe to AI Daily News 100. Inside a secret Shenzhen lab, a team of engineers reportedly achieved the impossible, building a working EUV prototype in early 2025. This wasn't a cleanroom by-the-book operation. Sources claim it was a masterclass in reverse engineering and sheer determination, using scavenged parts from older, less advanced DUV machines, components acquired through clandestine global supply chains, and crucially, poaching ex-ASML talent with deep institutional knowledge. All of this was fueled by a torrent of state cash, a blank check from Beijing to break the West's technological blockade. Stay informed on the tech Cold War. Subscribe to AI Daily News 100. Now let's be clear, the prototype can generate EUV light, the foundational step, but it hasn't made final commercially viable chips yet. Achieving high throughput and yield, meaning producing millions of perfect chips quickly, is a monumental challenge that takes years to master, but simply creating the light source is a quantum leap. This initiative is a government-led Huawei-linked Manhattan project for semiconductors. Its single goal: to cut dependency on US and allied supply chain ties, which have been used to stifle China's tech ambitions through strict export controls. But huge hurdles remain. The core of an EUV machine is a system of impossibly complex components. First, the ultrafine mirrors. Made by Zeiss, another German monopoly, these are the smoothest surfaces ever created by humanity. If you scaled one to the size of Germany, the largest bump would be less than a millimeter high. China must now create these from scratch. Then there's the precision optics needed to guide the light within a vacuum, since EUV is absorbed by air. And the light source itself, a high-powered laser, blasting a microscopic droplet of molten tin 50,000 times a second to create a plasma that emits EUV light. Synchronizing this is a nightmare of physics and engineering. Don't miss critical updates. Subscribe to AI Daily News 100 now. Despite these challenges, the timeline has been radically compressed. What experts believed would take decades is now projected for mass production readiness by maybe 2028, 2030. If this is true, the entire semiconductor map just got violently shaken. It would mean US sanctions have not only failed to halt China's progress, but have instead created a powerful, self-sufficient, and state-backed competitor. The implications are staggering. It could lead to a bifurcated tech world with two competing standards, or a flood of low-cost advanced chips from China, disrupting established players like TSMC, Samsung, and Intel. The tech Cold War just went from chilly to Arctic. The race for the future is on, and a new player has just entered the arena.